So we looked at the oxygen dissociation curve, and if you remember, we said that different species make different kinds of hemoglobin that differ slightly in their shape. However, this slight difference will cause a difference in the oxygen affinity. This means we should have different oxygen dissociation curves for different species. All of them will have roughly the similar shape, however, they will differ in the position on the axis. Just remember that the greater you go left, the greater the affinity of hemoglobin is towards oxygen, which means it will load oxygen readily, but will unload oxygen with difficulty. The further right you go, the lower the affinity for oxygen. So you have less easy loading, but more easy unloading. And we said that the hemoglobin is going to change its affinity for oxygen depending on the amount of carbon dioxide present. The greater the carbon dioxide present, the more readily hemoglobin will release oxygen. This is known as the Bohr effect. So at the lungs, we have low carbon dioxide, which means we have a higher hemoglobin affinity, and we have a high concentration of oxygen in the lungs. So we have very easy loading of oxygen by hemoglobin. So the dissociation curve will shift to the left if we're talking about hemoglobin at the lungs. If we're talking about oxygen dissociation in respiring tissues, like in muscles, here we have a high concentration of carbon dioxide. So we have a lower affinity of oxygen, and we have low oxygen concentration at these muscles because they use all the oxygen they get. So the oxygen dissociation curve of hemoglobin at rapidly respiring tissues is shifted to the right.